All right, let's go over the warm-up. Something I want to point out about each of these problems is that each radical does not have an index. All right, anytime that happens, then that means your index is just the number 2. So that means each of these problems are square root problems. All right, so let's now do number 1. Anytime I see a constant under my radical, I like to break it down into a factor tree. So first I'm going to break down the 72 into 2 times 36. And if I come across a prime factor like the number 2, I'll leave it alone and I just keep going with the other number. So I'm going to break down the number 36 now. That's 12 times 3. 3 is a prime factor, so I'm going to keep going with the number 12 now. That could be 6 times 2. 2 is a prime factor, so I'm going to keep going with the number 6 now. That's 3 times 2. And now I've got all of my prime factors. And basically the prime factors are all of the numbers that did not branch off any further. All right, so now I'm going to find pairs. And I know that I'm supposed to find pairs, groups of 2, because my index is the number 2. So I've got a matching group of 2 right here. I've got 2 2s. Your matching pairs will go on the outside of the radical. I've got a matching pair of 3s. Those can go on the outside of the radical. And the number left over is a number 2 that did not go in a pair. So I'm going to write 2 on the inside. And when we simplify this, we get 6 square root 2. And that's it. All right, so now I'm going to do number 2. Once again, like I said at the beginning of this video, anytime you do not see an index on your problems, the index is 2. And the index is letting us know how many groups we're supposed to pull out and what types of groups. All right, so we're supposed to pull out groups of 2 from the number 18. And the best way to do that is just to divide the number 18 by 2 and see how many full numbers we get from that. Or whole numbers, I guess I should say. All right, so I'm going to write down my variable. And 18 divided by 2 is 9, and there's no leftovers. It's just 9, just a whole number. All right, so there we go. That one's equal to x raised to the 9th power. So now I'm going to do this next one. Once again, no index, so we just put a 2 there. And if we did 9 divided by 2, that would actually give us 4.5, or 4 with a remainder of 1. So I'm going to put the 4 on the outside, and I'm going to leave the remainder on the inside, x to the 1st power. And that's how you do this one. And that's our final answer. All right, so with this one, now we're going to combine the two things. We've got the constant and we've got variables. So first I'm going to break down the constant using a factor tree. I think I'm going to do 5 times 9. 5 is a prime number, but we can break down 9 to 3 times 3. And now we've got all of our prime factors. There's 2 3s. I'm going to write those on the outside. I'll keep the 5 on the inside because it did not go with a pair, didn't have a matching number with it. And now we're going to do the variables. Remember, if the index isn't there, then it's just 2. So to figure out the square root of x squared, we'll just do x raised to whatever 2 divided by 2 is. So that's just 1. And now I'm going to do y to the 5th power. We can take out 2 groups of 2 from the y, and we'll be left over with 1. And so there's our answer. All right, last. Now we're going to do number 5. This is like the finale problem. Okay, it looks a little crazy, but I'm going to start it the same way. I'm going to break down the constant under the radical using a factor tree. Let's do 2 times 40. All right, now I'm going to break down 40 to 2 times 20. Going to break down 20 to 2 times 10. breaking down the 10 to 2 times 5. And now we've got all of our prime factors. All right, now I'm going to write all of my pairs, matching pairs, on the outside of the radical. First, I'll write what was originally there. And now I'm going to start with the pairs. So we've got a group of 2 2s. And we've got another matching pair of 2s. And a 5. All right, and the 5 went on the inside because it was a leftover. It didn't go with a pair. All right, so now I'm going to simplify this, and then I'll do the x and z part under the radical. So 5 times 2 is 10 times 2 is 20. And let's keep going now. X raised to 7. Remember, if you don't see an index, then it's just 2. And we can take out 3 pairs of the x's, and there's 1 left over because it's an odd number. Now I'll do the z. We can take out 4 pairs of the z, and there's 1 left over. All right, let's simplify more on the outside, and then we're done. We're multiplying like bases here, so we need to add the exponents. Nothing to do with z to the 4th power. And here is our final answer.